Hello everyone, welcome back. In this video, I will be covering section 3.4, just about chain rule. So earlier in the other videos, in section 3.1, 3.2, 3.3, we saw different rules starting from power rule and how power rule can be applied to differentiate a polynomial. Then we also saw a derivative of a base being a variable, a number, and the exponent being a variable, just like derivative of a to the x type. Then we saw some product, some difference product rule, quotient rule, and then we also saw some derivatives of trigonometric functions. Now we are going to see what chain rule is. This is also a very important topic. How would you differentiate f of x equal to square root of x squared plus 1? Okay, now we have seen earlier, if f of x is square root of x, we can recognize that as x to the power 1/2, and the derivative can be applied by power rule. This exponent x to the power exponent minus 1, which is 1/2 x to the exponent negative 1/2. But we have not seen anything like something like this, square root of x squared plus 1. How do we differentiate that? There is no way we can expand this either, right? We cannot write this as square root of x squared plus square root of 1, and that's not okay here. So what is the best way to do this? First, in order to recognize the function f of x equal to square root of x squared plus 1, we will see this as a composite of two functions. So if I consider g of x equal to the expression inside the parentheses and f of x equal to the one outside the parentheses, which is something like x to the power 1/2 or square root of, let's say, uppercase x, then what is f composite g of x? We know that by rule it is f of g of x. So it is f of inside out, inside first, which is x squared plus 1. Then we have to do the outside. The outside is square root of x. That x gets replaced by the inside. So this is our f of x. So the given function square root of x squared plus 1 can be written as a composite of two functions, f and g. So this is the basic idea, or in other words, chain rule is applicable when you are able to recognize a function as function of a function or composite function. So what does the chain rule say? If g is differentiable at x and f is differentiable at gx, then the composite function uppercase f, which is lowercase f, composite g, is defined by f of x equal to f of g of x, which is differentiable at x, and f prime, uppercase f prime, is given by the product f prime of x equal to f prime of g of x times g prime x. In other words, if you keep the inner function as, say, u, if you keep the inner function as, say, u, if y equal to f of u and where u is a function of x, then dy by dx will be the outer derivative dy by du times du by dx. Okay, so it's outer derivative keeping the inner function as is times inner derivative. All right, so we can write this f of x. So we will do the problem here. F of x equal to, we want to write that as square root of u, where u is the inner function, the one inside the radical, which is the radicand. So f prime x can be written as dy by du times du by dx. So dy by du is derivative of square root of u. So that will be 1 over 2 square root of u. So it is 1 over 2 square root of u. Then what is du by dx? That is derivative with respect to x. That will be a 2x. So 2x. So these two cancel out. X over square root of u. What is square root of u? Square root of x squared plus 1. So if you apply the chain rule, the answer becomes 1 over square root of x squared plus 1 times x. So the way we use this, easy way, so if you use the fact that it is outer derivative times inner derivative, that is our f prime x. Outer derivative is derivative of this, derivative of this one. If you have a square root of something, how do you do? It is 1 over 2 square root of that something. That something is x squared plus 1 here. Then the derivative of the inside, that will be derivative of x squared plus 1. So it is 1 over 2 square root of x squared plus 1 times derivative of x squared plus 1, which is the inner derivative. This is the outer derivative. And inner derivative is the one inside the radical. So the 2 and 2 get cancelled out, right? It's 2x plus 1, 2x plus 0. 2 get cancelled out. So it is x over square root of x squared plus 1. The answers in both cases is the same, but outer derivative, if you do outer derivative times inner derivative, it will be faster. So for the next one, it's asking differentiate y equal to x cubed minus 1 to the power 100. So I can write that as u to the 100, where u equal to x cubed minus 1. So what is the derivative? Y prime, which is dy by dx, which is dy by du times du by dx by chain rule. So dy by du is I have to differentiate this with respect to u, that is exponent u to the exponent minus 1. Then derivative of the inside, which is x cubed minus 1 prime, which is 100. If I change the u back to x cubed minus 1, I'll get that. Then derivative of x cubed minus 1 is a 3x squared. So it is 300. There is 100, there is a 3. 300 x squared times x cubed minus 1 to the power 99. That is y prime here. Next example, find f prime x if f of x equal to 1 over cube root of x squared plus x plus 1. So we want to write this f of x in a different way. So 1 over cube root of anything x squared plus x plus 1. So 3 is the index. So denominator, if you write that in the exponent form, it becomes x squared plus x plus 1 to the power 1/3. If I take that to the numerator, I get x squared plus x plus 1 to the power 1/3. So now you can write this as u to the power negative 1/3, where u is the one inside the parentheses. So what is the derivative by chain rule? Outer derivative times inner derivative. What is the outer derivative? Which is, in other words, dy by du times du by dx. The outer derivative is dy by du. The inner derivative is du by dx. The outer derivative is derivative of this u to the negative 3. So it is negative 1/3 u to the negative 1/3 minus 1. Then derivative of u, which is x square plus x plus 1 derivative. So it is negative 1/3. Replace the u by x square plus x plus 1 to the power negative 4 by 3. Then x square plus x plus 1 derivative of x square, which is 2x, derivative of x, which is 1, derivative of 1, which is 0. So you can write the same thing as negative 1/3 x square plus x plus 1 to the positive 3, because you are bringing the negative exponent to the denominator and making it positive, times 2x plus 1. That is our f prime x. So let's try some problems based on chain rule. Let's take a problem number 21. Okay, let's do first number 9 and then we'll do 21. Number 9 first. So find the derivative of f of x equal to square root of 5x plus 1. So here we are going to apply the chain rule. So for that, you call the integrand, or call the radicand as u, square root of u, where u equal to 5x plus 1, the expression inside the radical. So f prime x equal to dy by du, outer derivative, times du by dx, which is inner derivative, which is the outer derivative times inner derivative. So dy by du is the square root of u. When you differentiate, it becomes 1 over 2 square root of u. Then du by dx is derivative of 5x plus 1. It's 1 over 2 square root of u is square root of 5x plus 1. Then derivative of 5x plus 1 is just 5. Derivative of 5x is 5. Derivative of 1 is 0. So that leaves us with 5/2 square root of 5x plus 1. That is f prime x. Let's try number 21, which is uppercase f of x equal to 4x plus 5 to the power 3 times x square minus 2x plus 5 to the power 4. So we have to do first to consider this as u and v, where u equal to the first function and v equal to the second function. So we are going to apply the product rule. First step is to do the product rule. So f prime x will be u v prime plus v u prime. This is our step. We have to get back to the step. So what is u? Which is 4x plus 5 the whole cube. So what is u prime? So it is outer derivative. So use the power rule for the outer derivative, keeping the inner function as is, times derivative of the inside, which will be 3 times 4x plus 5 the whole square times 4, which is 12 times 4x plus 5 the whole square. So the way why we said this is 4, derivative of 4x is 4, derivative of 5 is 0. That's why. So we got the first part. Then what is our v? V is the second function, which is in blue. X squared minus 2x plus 5 the whole power 4. X squared minus 2x plus 5 to the power 4. What is v prime? Outer derivative times inner derivative, which is 4 x squared minus 2x plus 5 to the power 3. Then what is derivative of x squared? 2x. What is the derivative of 2x? Derivative of x squared, that will be a 2x. Derivative of negative 2x, that will be a 2. So if I pull the 2 out, I'll have 4 times 2. X squared minus 2x plus 5 the whole cube. 2 is taken out, you are left with x minus 1. So that is v prime. So for our f prime x, we'll substitute u prime, v prime in 1. So I'm starting up with the u, which is 4x plus 5 the whole cube times v prime, that will be, this will be 8 times x squared minus 2x plus 5 the whole cube times x minus 1. So it is 8 times x squared minus 2x plus 5 the whole cube times x minus 1. So v prime done, then v, so which is x squared minus 2x plus 5 the whole power 4. Then u prime is 12 times 4x. We are left with 2 times x minus 1 times 4x plus 5 plus 3 times x squared minus 2x plus 5. That is it. Then you won't have this 4x minus 5, because 4x plus 5 the whole square, then x squared minus 2x plus 5 the whole cube is taken out. So that's all it is. That is, now we have to simplify only this part. That's 4 times. So it's all algebra now. 4x plus 5 the whole square times x squared minus 2x plus 5 the whole cube. Then you have 2x minus 2 times 4x plus 5. So if you multiply, if you FOIL, that will become 8x squared minus 8x plus 10x minus 10. If you FOIL those two, then this part, it is just 3x squared minus 6x plus a 15. So f prime x would be 4 times 4x plus 5 the whole square times x squared minus 2x plus 5 the whole cube times 8x squared plus 3x squared, that will be 11x squared. And if we combine the like terms, negative 8 plus 10, that will be a positive 2. Positive 2 minus 6, that will be a negative 4. X, and then the numbers, negative 10 and positive 15, that will be a positive 5. So that will be the product. That will be the value of the derivative by applying the chain rule. Now, we'll try a problem which says practice test and practice final. Number 43, y equal to sine of e to the x over 1 plus e to the x. So we have y equal to sine of e to the x over 1 plus e to the x. So this is again a function of a function where outside function is sine of x. The inside function is e to the x over 1 plus e to the x. So you can consider this to be sine of u, where u is the one inside the parenthesis. You can either way look at it. You can consider y as f composite g this way, or you can also consider y as sine u, where u equal to the inside function. Both are function of a function type. So dy by dx will be, so I can use outer derivative times inner derivative kind. The outer derivative is derivative of sine, the inner derivative is derivative of the guy side, derivative of u. So I can write that as dy by du times du by dx. The outer is derivative of sine u. So it is cosine u. Keep in mind, we have to change the u back to x. Then derivative of u, which is derivative of the inside, which is e to the x over 1 plus e to the x, a derivative. So it is cosine of u. What is u? U is e to the x over 1 plus e to the x, that is the outside. Then the derivative of the inside, for that you have to apply the quotient rule because it looks like a quotient. So you can apply the numerator, consider numerator as u, denominator as v. So u is e to the x, v is 1 plus e to the x. So what is u prime? E to the x. What is v prime? Derivative of 1 is 0, derivative of e to the x is e to the x. So now if you apply the quotient rule, v u prime minus u v prime over v squared. So don't change the order in the numerator. That will change the sign of your answer. So cosine of e to the x over 1 plus e to the x for the outer derivative. For the inner derivative, we will substitute v, which is 1 plus e to the x. That is v. Then u prime, that is e to the x. U, that is e to the x. V prime, that is e to the x again, divided by v square, that is 1 plus e to the x, the whole square. So f prime dy by dx would be, so dy by dx would be cosine of e to the x over 1 plus e to the x, and times, you have to simplify these, which is e to the x, distribute the e to the x. E to the x times e to the x is e to the 2x. And minus e to the 2x divided by 1 plus e to the x, the whole square. We don't want to by mistake combine this expression with the argument of cosine. So we write the expression inside that bracket as a separate expression outside times cosine of e to the x over 1 plus e to the x. That is dy by dx. So it's a good practice to practice all the additional suggested problems as much as you can, because some of them are already in homework. And there are some more problems that are done in the chapter videos as well. In this concept video, we have done problem number 9, 21, and 43. Check my other videos for this chapter. So I'll be doing the next video on 3, 5. So please watch that video.